Hey guys, welcome back. Alright, today we're going to talk about compound interest and the equation we can use for compound interest. This is a nice application of our growth functions. So if you have the slides, you can go ahead and open those. I'm going to start on slide 1 here. So slide 1, kind of define what compound interest is. So compound interest in general is just interest that you earn that's going to be based on the initial investment that you have and previously earned interest. So it's not just like you are getting interest, like the interest is accumulating and then it's being added into the principal. Okay, and it's a really nice application of exponential growth. So we'll have our equation, and it's set up in the first slide. But here's the equation. It's A equals P times the quantity 1 plus R over N. That whole quantity is being raised to the n-th power, the n times t power. Now there's some important things to point out here. So here's our equation. A is going to represent our current amount. And P is going to represent your initial amount, or the principal. So this will be P for principal. Or we can call it the initial amount. It's what you start with. So the initial amount. And we have the R and T. So R and T, those both are going to be like what we worked with a growth function. R is still our rate. In this case, it's going to be specifically the interest rate. And T is going to be our time still. And T will be in years. So T is time. Let's reverse that. T is time in years. And if you look at this, it's really almost the exact same as the growth function. Main difference is instead of just plus R, it's plus R over N. And instead of to the T power, it's going to be to the N times T power. So this new N is coming in here. And what the N is, and this is compound interest, so the N, which we have two of them, we have right here and here, the N is going to be the number of times that the interest is compounded each year. So the number of times the interest is compounded each year. So if we were compounding the interest monthly, then you would have 12 in both of these, because it would be 12 times in the year. If you compound the interest quarterly, you'd have a 4 in here, because you're going to compound it 4 times. If you compound it weekly, you'd have a 52 in here. Maybe if you compound it annually, that would mean you compound it once, so you would have a 1 here, which would be really nice, just a growth function. And if you compound it semi-annually, you'd have a 2 in there. So there's different amounts of time you can compound for the year, and that's what the N is saying, how many times you have compounded. Okay, so let's hop into an example. What's nice about this is once you know what everything represents, you can just substitute in and solve for what you need. So let's hop into our first example, and that is on slide 2. So on slide 2 it says, Amanda's parents invested $14,000 at 6% per year, compounded monthly. And we are going to find out how much money there will be in the account after 10 years. So go ahead and set up our equation. That would be our A is equal to the principal times the quantity 1 plus r over n. And that quantity is being raised to the nt power. And we can substitute in what we know and then solve for what we don't know. So what we know is Amanda's parents invested $14,000. That's the principal. That's the initial value. So we're looking for the final value, or the current value, after how many years. That's what A is. But we know 14,000. We have the 1. We're going to increase. Compounding is going to gain us some money. And we are told that it is compounded 6% as your rate. So remember, that's 0.06 as a rate. Over, it's compounded monthly, so that n is going to be a 12 because it's compounded monthly. And then we can add in our 12 up here in the exponent. And we're told we want to know how much money we have after 10 years. So that t is in the unit of years. So we just need to simplify and find out what a is. It's just a simple plug in and solve. So let's go ahead and simplify. Had to grab my calculator. So order of operation tells us to simplify in the parentheses first. So we'll leave it as a decimal in there. We're going to have 1 plus and do our 0.6 divided by 12. So we're going to end up with 1 plus, when we simplify this, we should have 0.005. And we're raising to the, we can simplify that to 120th power. So A will equal 14,000 times the quantity 1.005 to the 120th power. Order of operations says we have to do this first. So let's raise that to the 120th power. And we'll have our final value is going to be equal to the 14,000 times, after we raise this to the 120th power, we end up with this really long decimal. Now if you're using a calculator, you can just save your answer and reuse that. I'm going to round it off right here. And then you multiply that by your 14,000. Oops. Times our 14,000. There we go. So we should end up with A is equal to, we have 25,471.55. With money, you're going to round 2 places. So that means after 10 years, Amanda's parents have $25,471.55 from that investment. So it's grown from the $14,000 to $25,471.55. Alright, so that's how these problems work. Just substitute everything into the right spot. So let's try problem number 2. And this problem is talking about Elliot. Elliot's investing some money, wants to get in the game. So Elliot invested $400 into an account with a 5.5% interest rate, and it's compounded monthly as well. And we're going to find out how much Elliot's investment will be worth in 8 years. So let's write our equation. A is equal to our principal times 1 plus our rate over the times we're compounded in a year times the amount of years multiplied by our number of times we're compounding. So we're finding our total value after 8 years. So that's what we're gonna find. And we'll substitute in a 400 for our principal. That's what Elliot's starting with. And we're going to have 1 plus, now 5.5%, it's going to be 0.055 over 12 to the 12 times 8 power. So let's go ahead and simplify. So to simplify, you do your parentheses first. So we're going to have 0.055 divided by 12, and we're going to add that to 1. So we have 1.004, and I'm going to round it up to 6, But if you're using a calculator, just use the answer you have, do less rounding, and actually I'll simplify up here. 12 times 8, we should get 96. So this is being raised to the 96th power. So our final value will be 400 times the quantity, 1.551. We'll round it there. Again, using the calculator, just save the last answer, do all rounding at the end. Multiplying this by 400. So Elliot's investment, we have 620, and now we're going to round to the nearest hundredth, working with money. So Elliot has, after 8 years, his investment is worth $620.46. Okay, so that's how compound interest works. I'll give you some practice problems to try on your own. Make sure you have them down. It's all about just substituting everything into the right place and then following your order of operations. Alright guys, that's all for today. Enjoy the rest of your day.